All right. We took a little break, but we are back to it, and we are doing number 6 this time. And number 6 is an extension from number 4. And so if you haven't watched the number 4 problem, we just did it. Go ahead and watch that. And so it says, refer to problem 4. Assume that the population variance of the difference in blood pressure D is unknown. Determine point and 95% confidence interval estimates for the population variance. Write an interpretation of the confidence interval. So let's do a recap. When we were doing estimates for means, okay, with a known standard deviation, we use a DZ distribution. Estimating for uncertainty of means or without the known population standard deviation, well, we'd use a T distribution. What about variances, though, which we're doing here? Well, that's where the chi-squared distribution will come in, and formula will come in, where that will encompass the sum of the squared standardized normal deviations. That's what it encompasses. So when it comes to variances, we're going to be using the chi-squared distribution. So let's go ahead and start there. So let's go ahead and do the first thing here that it's asking us, just determine point estimates for the population variance, where we know that for point estimates, right, sigma hat, if I could do better, sigma hat squared is equal to our sample variance, which here we know we have a sample standard deviation of 19.85 squared, which comes out to 394.02. So we're going to need this later, so let's go ahead and put that in our back pocket here, 394.02. Okay, but so we've got the first part of the problem down. Now it's asking us to do a 95% confidence interval estimate for the population variance. Okay, well, let's start off with, we know that we're going to be using the chi-square distribution, so let's go ahead and write the test statistic for that, which looks like this, okay? Minus 1 s squared over sigma squared, okay? All right, and so let's go ahead and put this one to the side as well. So let's go ahead and put both of these to the side as well. Give us some space here on the right-hand side. And a good way to kind of go about this problem is to visualize it. So let's go ahead and do that. And I'm going to put it here on the top right of the screen, okay? And chi-square distribution will look something like this, okay? And it's asking us to do a 95% confidence interval. 95% CI is equal to 0.05, right? And what does an interval entail, right? Well, we have, we're assuming, or we want to assume that we're some percentage confident that our parameter is within X and Y. And so that will push us to do our alpha divided by 2, and that might look something like this, okay? Maybe I'll draw it like this. This is a little bit big, but just for visual purposes, okay? This is 0.025, because this equals 0.025. And then over here, okay, is 0.0025. And we're saying that in here is our 1 minus alpha, because these two on our left-hand and right-hand sides is alpha divided by 2. This is alpha divided by 2. All right, and we're saying that our parameter, or the thing that we're looking for, is within these intervals at our chi-squared at 0.975, which is our 1 minus 0.25 here on this side, and our chi-squared at 0.025 on this end. And we're saying that it's somewhere in here, okay? That's what we're saying. And so let's go ahead and write this out algebraically, okay? We're saying that this here, that has what we're looking for within it, is within that interval. So on the one hand side, we have this. We have our chi-squared at 0.975, and our chi-squared test statistic, minus 1 s squared over this, let's go ahead and move this down a little bit so we're not cramped for space. We have a lot of space in here. It's not what I wanted to do. Get out of there. Is at 0.025. 0.25. Okay. Or we can also call this, another thing we can call this is 1 minus alpha. And then let's go ahead and just call this side, okay, at alpha, 1 minus alpha divided by 2. This is alpha divided by 2. Okay, but what we're looking for is we're looking to do a confidence interval for the population variance. And what is population variance denoted by? Well, that's denoted by sigma squared, which we have here. Okay, so that's what we're looking for. So let's go ahead and isolate that. Let's go ahead and isolate that. Okay, this is what we're looking for. And might fast forward this part if you're not interested in the how we get from one to the next. Okay, but first thing we want to do is we'll go ahead and turn these around and flip our confidence interval so that we can have our sigma squared on top, and that'll look like this. X squared, flip our interval, 2 on top, this 1 S squared, 1 minus, that looks like a 2 divided by 2. Okay, and then multiply this out, Rn minus 1 S squared. And that'll look like, apologies there. These are 1 over, 1 over, okay, since we're flipping it. And then multiply our n minus 1 s squared out, and that comes out to n minus 1 s squared over our chi squared at by 2 is, now we're left with this and our n minus 1 s squared at 1 minus alpha divided by 2. Okay, and so that's where we're at. What I'm going to do is actually take all of this so that we can fit it on one page. Okay, we're going to head and make this a little bit smaller. Yeah. Okay, there we go. Now we can fit a lot more things onto this one page. Okay, and so this is really kind of where we're at and what we're looking at. Okay, and now we can kind of work with this, right? Now we know that our population variance, sigma squared, is in a place where it's in between values that we can calculate for. Well, let's do that. Let's calculate for them, and let's do the top half of this first. So n minus 1, which is equivalent to like our degrees of freedom, right? And we, referring to number 4, is we have 10 patients. Okay, so forgot to write that down earlier, but we have our n equals 10. So n minus 1 is equal to 9. And our sample variance, which we got earlier, which was 394.02, over our, and we'll get the lower quartile for chi-squared in a second. I'll just write the rest of this out for visual purposes. Okay, this one is 394.02. All right, now let's go ahead and get our lower, okay, lower quartile and upper. Okay, so one way we can do this is we can look at the chi-squared, what's it called, distribution table. But another thing we can do here is we can do it in R. So let's go ahead and put these in. I did these and pre-enter these in. So our n equals 10, our degrees of freedom at n minus 1, our sample variance at 19.85 squared. And then we can calculate for our chi-low by putting our 0.975 for our left-hand side and assigning our object degrees of freedom for our right-hand side. And then same thing with our chi-high. Okay? Now that we've got those in, we see our values down here for our chi-high and chi-low. Okay? Now our lower variance. Okay? We can assign this object, lower variance, for our degree of freedom times our sample variance divided by our chi-low, which is, let me re-share my screen, okay? That is equivalent to this. That is equivalent to this. Okay? That is our degrees of freedom, right? df times our s squared over our chi low. Okay? So let's now go back and calculate that. Okay? And we get that lower variance of 186.4188. And then let's go ahead and do that for our upper, right? And then we can go ahead and string these along into one, and we get this value here at the very bottom. So this now has calculated for us what our confidence interval is in between. But let's go ahead and go back for a second and write this in. You know, you can go ahead and copy that code too if you wanted to. But for our chi-low, oh, I should have wrote it down. But for our chi-low, we had 2.7, and our chi-high, or chi-low is 19, sorry, at 19.23. Let's do 0.023 and 2.70. Okay. And that is equal to, and give me a second, everybody. I'll show you my screen in 1 second. Thirteen point. Okay. And while we're here, let's go ahead and get these out for our lower standard deviation. Well, we'll do that in a second, actually. Back to reality. So now we've got our 95% confidence interval, right? Written out in algebraic form. Okay, and we're almost done here, right? We've done the confidence interval, and we can say that we are 95% confident that our value, okay, our population variance lies between 186.4189 and 1313.2189. Okay. And the last thing that we can do to kind of top this off is do the standard deviation. Okay. So now we can go and get the lower standard deviation by doing the square root of our lower variance, and then the upper standard deviation, upper variance, and then string these along so that we can see those answers side by side. And we get 13, so SD equals 13.653, 36.238. Okay. And to end off the video, we can see our final answers here for our standard deviation and our 95% CI confidence interval. Nice. So that's it right there. If you have any questions, feel free to drop it down below. And yeah, I mean, this is a learning opportunity for me, be able to explain my way through each problem. So yeah, hope that made sense. Thanks, everybody. I appreciate you guys. Get to my screen. Let's end with this. Later, everybody.